Hi children, in the previous video we discussed the worksheet from 1, right? From that second concept, what is that? Whole numbers, worksheet 1 problems we discussed. In this video we are going to discuss the problems from worksheet 1A. Okay, let us see here what is the first question they given. If x and y are any two whole numbers, x and y are any two whole numbers, just like that a and b are any two whole numbers, then what about that a divided by b? And in the same way here they are asking for that instead of that a and b, here they get taken that x and y. So what about that x divided by y? Let us see here. A belongs to whole number, b belongs to whole number, a belongs to whole number, b belongs to whole number. As per the given question, x belongs to whole number, y belongs to whole number, a divided by b belongs to what they are asking, and in the same way x divided by y belongs to what they are asking. Understood, ma? Actually we are saying that AB words, right? AB letters we are using, they given here x and y letters they given instead of that a and b. Here x belongs to whole number, y belongs to whole number. What about that x divided by y? Okay, see here, ma. Let x is equals to 4, y is equal to 6. Any two numbers. Okay, 4 belongs to whole number, 6 belongs to whole numbers. Then x divided by y is equals to 4 divided by 6, which is equals to 2 2's 4, 2 3 6. 2 by 3 does not belongs to whole number. Does not belongs to whole number. Why? Because 2 by 3 is a rational number. That is not a whole number, right? And in the same way, this is first example. Take that second example. If x is equals to 4, y is equals to 2. 4 is a whole number, 2 is also a whole number, right? Now here x divided by y is equals to 4 divided by 2. 2 1's 2, 2 2's a 4. 2. So 2 belongs to whole number. This is case 2. Okay, and this is case 1. Just observe that those two examples, ma. Here, if x is greater than y, if x is greater than y, then we are getting a whole number. Okay, but this is not always possible. For example, here if x is equals to 1, y is equals to 2, x divided by y is equal to 1 by 2 does not belongs to whole number. Okay, when that x is a multiple of y, then only this is possible for that to get whole numbers. Okay, and here remaining times we are getting here rational numbers. So as per this one, here what we can say that here when you're sometimes we will get that whole number, sometimes we may get that other than whole numbers. Okay, other than whole numbers means those are maybe here rational numbers or irrational numbers. That is depends on that given one. Okay, irrational numbers means that one also depends on that. If a and b are any two irrational numbers, then also we can use that property. Understood, ma? But that is not required here to you. So just a and b are any two whole numbers, then what will be possible here? Always there is a chance to get that rational numbers, or always is there a chance to get that whole numbers? That is, we cannot say that, right? So sometimes we may get that whole numbers, sometimes we may get that rational numbers. Understood, ma? So as per this one here, x and y are any two whole numbers, then x divided by y. Always whole number. That's what I am saying. Always whole number we are not getting here. Okay, that's why this is wrong. Never be a whole number. We cannot say that here we are getting a whole number. Okay, so that's why this is also wrong. Maybe a whole number. Yes, there is a chance to get that whole number, and there is a chance to get that rational number. Understood, ma? So there is a chance. Maybe means there is a chance. So this is possible. Completed. Next, is not possible always. Why it is not possible always? It is not possible to take that the value for this. Here we can take that fractional values as well as decimal values, and sometimes we may get that natural numbers or whole numbers. Understood, ma? So that's why this is also wrong statement. Finally, what is the correct statement here? That is may be a whole number. Understood? Yes. Next, second one. The predecessor of 0 in the set of whole numbers. Predecessor means here predecessor of any number, which means here just subtract minus from the 1 from that any given number, then you will get that it's a predecessor just before number. Okay, so predecessor of 0 is 0 minus 1 is equals to minus 1 and minus 1 does not belongs to whole numbers. Minus 1 does not belongs to whole numbers. Minus 1 is an integer, that is not a whole number, right? So that's why here that is does not exist in that whole numbers. So in that whole numbers, predecessor of 0 does not exist. In that natural numbers, which number predecessor is not exist, ma? Yes, of course 1. Predecessor of 1 does not exist in that natural numbers. Predecessor of 0 does not exist in that whole numbers. Okay, see here. As per this one, our answer is does not exist. Clear? Yes. 13th one. Which of the following is a property is not valid in whole numbers? Is not valid, they are asking. Okay. As per this one, what is the first one here? Closure property with respect to addition. Okay. Option A, what they are saying? Closure property. A belongs to whole number, B belongs to whole number, then A plus B belongs to whole number. This is first one. What is that? Closure property with respect to addition. This is closure property under addition. Okay. Next, closure property with respect to multiplication. Okay. This is a positive. And with respect to multiplication, A belongs to whole number, B belongs to whole number, and we know that A into B is also belongs to whole number. Yes or no? Just example, say that 2 plus 3 is equals to 5. Okay, 2 is a whole number, 3 is a whole number, 5 is also a whole number. And in the same way here, 2 into 3 is equal to 6. Okay, 2 is a whole number, 3 is a whole number, and 6 is also belongs to whole number. Understood, ma? So this is related to closure property. Closure property under multiplication. Closure property under multiplication. And come to the third one. Closure property with respect to subtraction. Closure property with respect to subtraction is invalid, they are asking. No. So A belongs to whole number, B belongs to whole number, and here A minus B. Here there is a chance for that belongs to whole number. A minus B does not belongs to whole number. Why? Because see here. Take the example. If A is equals to 5, B is equal to 6. A minus B is equal to 5 minus 6 is equal to minus 1 does not belongs to whole number. Minus 1 does not belongs to whole number. That is the reason. And always is it possible, ma? Always that one not possible. If A is equal to 6, B is equal to 5, then 6 minus 5 is equal to 1 belongs to whole number. Okay, sometimes we will get that whole number, sometimes we did not get that whole number. Understood, ma? That's why here this is invalid property. Okay, that's what they're asking. No, here not valid. This is not valid. No, here. Okay, as per that one, that is the correct option. And here commutative property with respect to addition. Commutative property with respect to addition is A plus B is equal to B plus A. If you add 2 plus 3 is equal to 3 plus 2 is equal to 5 is equal to 5. So satisfying or not? Yes, of course it is satisfying. So as per this one, which one is not valid here? With respect to subtraction, not valid. And children, here in this case of natural numbers and whole numbers, here which one is not possible means under properties. Commutative property, associative property, closure property. Okay, and in the same way, see here, which one is not possible means addition and multiplication possible. Not possible means subtraction and division does not possible here, not satisfies here. Understood, ma? Yes. Let us see here next question number 4. In the set of whole numbers, the valid operation among the following is. Okay. As per this one, see here. A, what is that? 16 divided by 4 is equal to 4 divided by 16. We know that A divided by B not equals to B divided by A. Okay, what is the reason? Here 16 divided by 4 is 4 and 4 divided by 16 is 1 by 4. So 4 not equals to 1 by 4. Yes or no? Yes. Okay, ma? So that's why here this is the wrong one. Next, B. 16 plus 2 is equal to 2 plus 16. We can say this is commutative property. Commutative under under addition. Commutative under addition. This is satisfies, no ma? 16 plus 2 is 18. 2 plus 16 is 18. So 18 is equals to 18. It is satisfying or not? Satisfying. And what they are asking here, valid operation among the following. So see here, 1 minus 8 is equals to 1 minus 8 is equal to minus 7. This is does not belongs to whole numbers. Why? Because the negative numbers not there in the set of whole numbers. Understood ma? So this is also wrong one. And option D, what is that? 2 into minus 1 is equal to minus 1 into 2. What is the answer here? Minus 2 only, no? Minus 1 does not belongs to whole numbers, and here minus 2 also does not belongs to whole numbers. That's why this is also wrong option. Which option is satisfying ma here? Option B is satisfying. Clear? Yes. Next, fifth one. Multiplicative identity in whole numbers. So, multiplicative identity element is multiplicative identity element is 1. Why? Because here a into 1 is equals to a. Okay. If you multiply any number with 1, then again you will get that the same number itself as the resultant. Then here we can say that 1 is the multiplicative identity element. So 1 is belongs to whole numbers or not? 1 belongs to whole numbers only, no? So in the set of whole numbers, 1 exists or does not exist? Exists only, no? Then here what is the answer ma? 1. Identity element, what is that? Multiplicative identity element in whole numbers means that is 1. Additive identity element is 0. Clear? Yes. Next, sixth one is equal to, actually here this is in the form of 2015 into 2016 into 2017. This is in the form of A into B into C, which is equals to A into B into C. Okay, this is related to which property ma here? Yes, see here, this is related to associative property. Why? Because here 3 numbers given, no? So associative property under multiplication. Under multiplication. Okay, see here. Then A into B into C is equal to A into B into C. So here A is equals to what ma? 2015 into here set of 2016 into 2017. Just grouping difference only. Okay ma, there is no change in that order, just we are changing the grouping way. Okay, this is related to associative property under multiplication. So which option is correct here? 2015 into 2016 into 2017. A into set of B into C. Brackets of B into C. Understood ma? Which option is correct here? Option A is correct. Clear? Yes. Let us say that question number 7, what is that? The property related to the given operation. So what is that given operation here? 2016 plus 0 is equal to 0 plus 2016 is equal to 2016 in whole numbers. In whole numbers. So this is related to which property ma? Actually here 0 is there. So that's why this is related to additive identity element. And we know that this is in the form of A plus B is equal to B plus A also. No? Okay, A plus B is equal to B plus A. Okay, at that cases we will get that C as answer. But here we are getting that same number itself as the answer. That's why this is related to additive identity. What is the property ma here? This is additive identity. If it will be given as 2016 plus 0 is equal to 0 plus 2016, okay, then this is belongs to commutative property. Okay, but here this is in the form of, this is related to additive identity. A plus 0 is equal to 0 plus A is equal to A. Okay, here A given means again the number itself we are getting as the resultant. So that's why as per this one, here you may get the confusion, commutative also there, identity also there. Okay, but at these cases just you have to go for that identity only, don't go for that commutative. Why? Because here again the same number itself they given 2016, but here just observe that this is the difference between those two. Okay, here we are getting the answers 2016 and simply they given like this means that is commutative property, under addition we can consider it. Okay, but here 0 given as well as answer also the resultant itself they given. If you add 0 in any order to any number, then you will get the same number itself as the resultant. At that cases that is related to additive identity. Understood, ma? Yes. Next, 8th one. The true statement among the following is, the true statement among the following is, set of irrational numbers is finite. Okay, what they are saying? Set of irrational numbers. So Q dash, the set of irrational numbers are finite, they are saying. How they can say that finite? Here in that irrational numbers we are having that whole numbers, natural numbers, integers and rational numbers also. Okay, these all are that, just to say that irrational numbers means we can take that as set of, square root of 2 is there. Square root of 2 is irrational number only, no? Square root of 2. Square root of 3, that is also irrational number. So here 2 belongs to whole number and as well as that is belongs to natural number, and whatever it may be, here we can consider this one as here the set is infinite. Okay, why? Because root 2, root 3, root 5, root 7, root 11 and so on. These all other numbers are irrational numbers only, no? Okay, so we are having how many irrational numbers? How we can say that? We cannot say that. Okay, square root of 111, we cannot say. Square root of 10 ones. Is it possible to find that square root, ma? Okay, exact square root we cannot find for that, right? So that's why here irrational number set is also infinite. That is a finite they given. That's why this is wrong. Understood? Next, set of whole numbers is less than 100 is infinite. So set of whole numbers less than 0, 1, 2 and so on. Less than 0 means up to 99. So up to 99 means totally 100 numbers are there. So this is a finite set or infinite set? This is a finite, but they given here infinite. Okay, set of 100 numbers. So we are calculating that. There is a limitation in that numbers, right? Limited numbers there. So that's why that is a finite, but they are saying infinite. So that's why second statement also wrong. And come to that next. Set of whole numbers is infinite. Yes, of course, set of whole numbers is equals to 0, 1, 2, 3 and so on. That is infinite set only, no? So that's why this is satisfying. Set of integers is not finite, not infinite. Not infinite means a finite only, no? Not infinite means that is a finite they are saying. Set of integers are finite or infinite, ma? Minus 1, 0, 1 and so on. So here infinite only, no? Minus infinity to plus infinity. Okay, negative numbers, infinity numbers there, positive numbers also infinity numbers there. Understood? But they are saying here finite. Not infinite means that is finite only, no? Okay, that's why this is also wrong. So which option is correct here? Option C is correct. Okay, children, in this video we discussed 1 to 8 questions. Okay, these all are related to properties. Okay, ma. So before going to do that problem, just you have to go for that properties. All the properties once you check that. Okay, what is the property and that one comes under which property and comes under that which fundamental operation. Okay, ma. In that next video again we will meet with next continuation questions from worksheet 1A. Okay, thank you all.